Hello and welcome to Working Scientist, a Nature Careers podcast. I'm Julie Gould. This episode marks the launch of a new series on the podcast where we're exploring the relationship between art and science. Are they two separate cultures, or are they two sides of the same coin? Over the course of the series, I'll be sharing stories from artists who work with scientists, scientists who work with artists, artists who are scientists, and scientists who are artists, sharing practical advice on how to make this relationship work and why it's important for both disciplines to collaborate. In keeping with our art and science theme, each episode in this podcast series concludes with a follow-up sponsored slot from the International Science Council. The ISC's Centre for Science Futures is exploring the creative process and societal impact of science fiction by talking to some of the genre's leading authors. I've been excited about this series because I've spent quite a bit of time these last few years trying out different forms of art. Now, I am in no way an artist, but I do like to try new things and see what I end up with. I also find art a little bit like meditation. I get in the zone and focus on nothing else but the fine pencil lines or the gentle brush strokes. The kind of art I've been doing is mostly drawing and painting. I haven't ventured into sculpture or music yet, but you never know. But there are so many forms of art that I haven't really considered as art at all, which begged the question, what is art? I asked a few people that I've spoken to for this series to share their thoughts with me.
Hi, I'm Jessica Bradford and I'm Head of Collections and Principal Curator at the Science Museum. I think art could be any way of asking a question about the world, and we have every possible sort of format and response to that, whether it's early photography, religious statuary, contemporary video art.
My name is Nadav Drukker. I'm a professor of theoretical physics and the head of the theoretical physics group at King's College London, and a ceramic artist. And art creates objects that we enjoy to look at or listen to experience in some way.
I also asked British artist Luke Jerram.
A physical art object can be a way of communicating, a way of seeing from one person to another.
This is Jessica Bradford again from the Science Museum in London.
What connects all of those forms is fundamentally the question that they're asking of the world and the curiosity that drives their production.
Curiosity is a word that I, as someone who comes from a scientific background, mostly associated with the scientific endeavour. This led me to ask my next question. What is science? First up, Nadav Drukker.
So science is the process of uncovering the laws of nature, which is a creative process because we are discovering it for ourselves, even if it existed or exists without us and irrespective of our understanding of it. But science is the process of understanding it and creating knowledge.
It's a way of questioning the world, and it's the curiosity to look deeper into the universe, to ask questions about why things are the way they are, and to come at those questions with a sort of balance of imagination and rigour.
And Luke Jerram.
So science, again, is a way of seeing, a way of looking and interrogating the world, but also to do it in a way that is hopefully repeatable, to allow other people to see something in the same way again. I think it's that repeatability that's really important. Whereas art doesn't necessarily have to be repeatable, it can be abstract. and unproven, and that sometimes has some validity in the way that science doesn't.
So art and science are both endeavours of curiosity, trying to explore, uncover and express our world around us, but in different ways. This can make for very fruitful collaborations, says Ljiljana Fruk,
professor of bionanotechnology at the University of Cambridge and chemist by training and lover of art.
Scientists and artists have the same goals, she told me, but they reach them in different ways.
We scientists always need to back it up by data. Data and making the things takes time, and then you publish it. Whereas the artists, they can be a little bit more playful from the very beginning, and they can be faster in the way they translate certain materials, and it's in a creative way.
But sometimes these two approaches can be seen as a clash.
There's a nervousness on the part of scientists, sometimes, certainly not all, that an artistic mindset or presentation of their work somehow challenges the validity of their work and the notion of, I suppose, factual accuracy. And that's ultimately where those points of diversion come from. An artistic interpretation, or the notion of artistic license, is essentially code for inaccurate or false or fantastical, which is sort of the opposite of what we've said previously. And certainly, that most, I think, scientists would give credit to that the necessity of imagination and creativity in what they do. But I can also see that art has the freedom to be anything it wants to be, to break rules, to create images and shapes and a vision of the universe that is fundamentally opposed to the laws of physics, for example. Whether you would see that in opposition or not, I would sort of question that, because I think by presenting a particular vision of the world, it might draw into question or help you reflect more deeply on the way that physicists describe the world. So both are seen in dialogue rather than in opposition. I wouldn't want to live in a world in which there was only a single way of looking at it.
And there are so many examples in history of artists and scientists who did look at the world in multiple ways. I spoke to Arthur I. Miller, an author and emeritus professor of history and philosophy of science at University College London, and he shared a few examples with me. First, let's consider Leonardo da Vinci. His detailed and analytical drawings and sketches of aeroplanes and submarines were as important to him as his painting of the Mona Lisa. Or even Galileo Galilei, who studied art at the Florentine Academy of Art in order to record more accurately his investigations in nature. More recently, artists and scientists began influencing each other more directly than they had before, and the boundaries between the two cultures began to blur. Arthur told me that artists started using more scientific tools in their creative processes.
At the beginning of the 20th century, a rapprochement between art and science was established with a bang through the work of Einstein and Picasso. To Einstein, the equations of the physics of 1905, as they were understood, led to asymmetries which to him did not exist in nature. And he found this, as he wrote shortly afterwards, unbearable. Through a minimalist aesthetic, he cut down the number of hypotheses in physics at that time, and in this way discovered the special theory of relativity. It was one man's response to his aesthetic discontents. But Picasso used the aesthetic of reduction of forms to geometry to go way beyond current art, such as post-impressionism, to create cubism. In cubism, all perspectives appear at once and on a canvas. Towards this method, Picasso found advances in science, mathematics, and technology to be all important.
So as both art and science advanced, both artists and scientists started thinking along the same conceptual lines.
Now, these advances occurred because Einstein thought like an artist, and Picasso thought like a scientist. Einstein with emphasis on symmetries in science. And indeed, Einstein introduced the notion of symmetries and beauty into physics, which has become a means for doing research. But what both people emphasized, and which was extremely important for development, is to emphasize conception over perception. That is, thinking beyond the world of perceptions towards the invisible, towards increased abstraction.
In the first half of the 20th century, artists used scientific ideas, but not so much the scientific tools. Electronic equipment became available in the second half of the century, like the cathode ray tubes and later computers. And now, scientists had a means of creating art.
In the early 1960s, A. Michael Knoll, an electrical engineer at Bell Labs, that font of creativity, created what he called computer art. He did this on an IBM 7040, which was called a mainframe computer. It was as big as a room and had less power than your phone. Knoll came out with the idea of why not use the plotter to make pictures, to make images. And he made images, straight line images.
Knoll became known as the father of computer art. The work has been described as a combination of mathematical equations and pseudo-randomness. The mainframe computer he used was essentially a number cruncher. You give it a complex mathematical equation, the computer would compute the numbers, and out popped a plot. These straight-line images reminded me a little bit of the creations I used to make on an Etch-a-Sketch as a kid. And I'll put a link in the show notes so you can take a look. But really, they've got some fantastic names too, like vertical horizontal number 3 and 90 parallel sinusoids. This is an example where science has influenced art. Arthur also shared with me a famous example where art has influenced science. In the 1920s, the Danish physicist Niels Bohr worked on a concept called complementarity.
In 1927, a big conundrum was how to understand that an electron, that something, can be a wave and a particle at the same time. You can't image it, so you can't imagine it either. And here, cubism was important for Bohr.
Arthur believes, and it has been backed by others, that Niels Bohr spent time reading a book called Du Cubisme by artists and art theorists Albert Gleitzes and Jean Metzinger.
There was a particularly interesting passage in the book on cubism where they write, a cubist image is all perspectives at once, and you can pick out one at a time by walking around it. In other words, how you look at a cubist picture, that's the way it is. So for Bohr, how you look at an electron, that's the way it is. If you want to experiment on it, be a particle, it's a particle, or the experiment is a wave, then it's a wave. And that's his principle of complementarity, that an electron can be either a wave or a particle, or in some world, it can be both.
Here's Jessica Bradford again from the Science Museum in London.
Through most of history, scientists and artists haven't necessarily seen themselves in opposition or as distinct people or trying to do a different thing, that there has existed a sort of creative tension between artists and scientists throughout that period. And I think we see in examples of early photography is a good one. So the work of Anna Atkins and her cyanotypes, we have a number of examples in the collection where her artistic ability and her use of that methodology of creating cyanotypes drove scientific progress, in the sense that she was able to represent her botanical images in a way that was more accurate and clearer, and could be popularised. So it was her creative vision and her technical skill in a, I suppose, traditional artistic sense, in that she was creating a form of photography, but it was really in service of her or others' scientific progress. And I think that that's an example where she probably wasn't necessarily seeing herself as doing one or the other, but both.
In the next episode of this series, we're going to look a bit more closely at how artists and scientists collaborate. In particular, how deep artists delve into the scientific world when looking for inspiration. But before that, we have our sponsored slot from the International Science Council about the creative process and societal impact of science fiction. Many thanks go to the artists and musicians who have kindly agreed to let us use their music for this series. The music for this episode all comes from the Sounds of Space project by Nigel Meredith, Kim Cunio and Diana Scarborough. At the beginning of this episode, you were listening to Sunset Phosphorescence. We then heard Iridation and Prelude to the Afternoon of a Storm, before closing with Sunset Phosphorescence again.
I've always had a love of science fiction, and in the last few years, I've found myself returning to it as part of my professional research work because of the profound and powerful ways I believe it can shape our thinking about the future. I'm Paul Srivastava, and in this podcast series, I will be speaking to science fiction authors from around the world to get their perspective on how science can meet the many challenges we face in the coming decades, from climate change and food security to the disruption caused by artificial intelligence. I wanted to speak to leading science fiction writers, in addition to scientists, because they can offer us a unique perspective on these issues. They are, after all, professional futurists.
Science fiction hit me like a gong, like I was the gong and I had been hit, I was ringing.
In this first episode, I spoke with Kim Stanley Robinson, one of the foremost science fiction authors in the world. Over the past 4 decades, he's written many books, including my favorite, The Ministry for the Future, which is unique in giving hope to the challenge of climate change. He's also covered many themes like human settlements in space in his Mars trilogy and AI-powered quantum computers in the novel 2312, and has won pretty much every science fiction award going, sometimes more than once. Stanley has inspired generations of science fiction readers and writers. Our conversation touched on many topics, including the dangers of escapism, climate grief, and the myth of scientific objectivity. I hope you will enjoy it. Stanley, I want to begin with what got you interested in science, your personal connection to science.
When I ran into science fiction, I was an undergraduate at UC San Diego. I thought this is the realism of our time. This describes how life feels better than anything else I had read. So I began to get story ideas by reading general science magazines. You could take randomly any 2 articles out of Science News, combine their implications together, you have a science fiction story. Then I married a scientist. I got to see a working scientist at work. And then I myself was accepted into a program run by the National Science Foundation. So I got to see how NSF works as a grant-giving organization. And the NSF sent me to Antarctica twice. I got interested in climate science because a lot of the scientists down there were working on it. And now this is, I don't know, it's about 20 years of consistent effort on what you might call climate fiction.
Working with NSF, that is a very interesting part because very few people get an inside look at how grants making actually works. Here I want to begin by pointing out something that I just finished reading, a book by Douglas Rushkoff called Survival of the Richest, Escape Fantasies of Tech Billionaires. And all they were interested in asking him was, how do we escape the earth? And it made me think the possibilities of escapism are seeded into our minds by science fiction, maybe?
I think it is. And I myself am heavily implicated in this because my Mars trilogy is by far the longest, most scientifically plausible scenario for humanity turning Mars into a, quote, second home. That novel, while I regard it as a good novel, is not a good plan. I wrote it in the early 90s before we learned that the surface of Mars is highly toxic to humans. As an escape hatch for now, for tech billionaires or anyone else, it's useless. A lot of this escapism is done as a fantasy, in that there's a part of those people that knows perfectly well that it won't work, but they want a sense that if push came to shove and if the world civilization fell apart, they could somehow dodge that.
You're absolutely right. And it brings me to this question. Are there lessons for policymakers that can be drawn from science fiction?
To have science fiction be actually useful to policymakers, they would have to read some science fiction, but it would be best if it were curated by somebody that knows the field and can send them to good works of science fiction. And there's a lot of useless science fiction out there, repetitive, foolish, dystopian, etc. Sometimes a dystopia can say to you, you don't want to do this, but you don't need much of that before what you really need is interesting and engaging utopian fiction or people coping with damage successfully. People are given a sense of hope that even if there isn't a good plan, we might come to a good result anyway.
Yeah, I have been recommending that people read The Ministry for the Future. I'm asking scientists to read it because it really does open their minds to the positives. But how do we take the message, the positive message, the hopeful message that you're casting to the masses?
It's easy to imagine things going wrong since it's so remarkable that it's going even as well as it is. And in fiction in general, a plot is the story of something going wrong. So there's a gravitation, there's a tendency for fiction itself to focus on things going wrong so that plots can be generated. Now, the further elaboration of the plot is the characters coping with what's gone wrong and hopefully fixing it. And then if there is a powerful strand of utopian science fiction out there, then the future will begin to seem contested and not preordained to catastrophe. And scientists need to help on this front of saying to the world, you are alive because of science. Science is an attempt to make a better society, perhaps less monetary, less grasping. Right now, in the midst of our ordinarily grasping and capitalist world, science is a counterforce. So, to the extent that scientists are politically self-aware, they would do a better job. Because there's many a scientists that say, look, I got into science so that I don't have to think about politics. I just want to pursue my studies. And yet they are inevitably enmeshed in a political world.
Yeah, and I think scientists have this self perception of their profession where we center objectivity and we systematically remove subjectivity and values.
Well, this is a good point, Paul, because there is that myth of objectivity that science is pure and it's only studying the natural world. We need what John Muir called the passionate scientists, that the science is being done for a purpose, which is human betterment or the betterment of the biosphere at large. But if science began to understand itself as a religious act, that the world is sacred, that people should suffer as little as possible given our mortality and our tendency to fall apart, it's a pursuit that has a point. It's not just the objective work in the lab to see which molecule is interacting in which way. It's always also a political project and an ethical project.
So I'm hoping that more and more books like yours will become available, made required reading. If you have any parting thoughts about how we might bring about that integration of the sciences and the arts.
All scientists, as part of their training, should be required to take courses that teach what science is. The vast field of science studies that the humanities and social sciences have brought to bear on how sciences work, the self-reflection on what they're doing is never a bad thing. They should not be left naive philosophically or politically at the end of a scientific education. That any department could do, any university could do that and should do that. It would create a more flexible and powerful core of science workers to have that education. And so in terms of requirements, I think that should be done. A few science fiction novels included in that list, some philosophy of science. I mean, do people read Thomas Kuhn and The Structure of Scientific Revolutions? Well, I don't know, but they certainly should, to comprehend their own work.
Thank you for listening to this podcast from the International Science Council's Center for Science Futures, done in partnership with the Arthur C. Clarke Center for Human Imagination at the University of California, San Diego. Visit future.council.science for the extended versions of these conversations, which will be released in January 2024. They delve deeper into science, its organization, and where it could take us in the future. Join us next week to hear a fascinating discussion with another science fiction author, Karen Lord.